This is actually Mod 2 Lesson 12, not Lesson 11, Mod 2 Lesson 12 on Pythagorean Theorem. I'm going to explain an informal proof of the Pythagorean Theorem for you, okay? Now, this is not in any of your packets or in your workbook, but here it is. We're going to look at it from here. We've talked about Pythagorean Theorem. Oops, let me erase what I just did. We've talked about Pythagorean Theorem. It is a squared plus b squared is equal to c squared, okay? It's a way to find the side lengths in a right triangle. If you're missing a side length, you can use it on a right triangle only to find side lengths. A squared plus b squared is equal to c squared. C is always across from the right angle. It is the hypotenuse. Now, let's look at the triangle that we've got right here. I'm going to try to draw this off so you can see it. Let's see if I can draw a straight line. Here's our triangle. Here's one side of it. Here's the second side of our triangle. Here is the third side of our triangle. Okay? Now, its sides are listed as A, B, and C, and we know that C is always across from the right angle. Here's our right angle. It's across from it. It's called the hypotenuse. It's the longest side. What if the length of this side A is 3 units long? See, we've got units set up here, like on graph paper. 1, 2, 3. What if it's 3 units long? Okay. Well, what we usually would do with the Pythagorean theorem, that means 3 would go in for A, and we square 3. Well, what if you actually make a square that's 3 by 3? Okay, let's see, 1, 2, 3. Okay, that's 3 sides on here. 1, 2, 3, 3 units on this side. That means we have made a square that is 3 by 3, right? How many blocks are in there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 squares in there, isn't there? 3 squared is 9. Isn't that what we're doing with Pythagorean theorem? What if this side here is 4 units long? Let's count it. 1, 2, 3, 4. Okay, so we plug that in for B, but what we do is we usually square it, which means we're actually making a square where all the sides are B units long. Well, if this is 1, 2, 3, 4 units long, and this is 1, 2, 3, 4 units long, you got a square here. How many total units in it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so there's 16 blocks here. Isn't that interesting? Because if I square 4, I've got 16. Well, we're still looking for c squared, aren't we? Okay. When we're normally solving this, before we cross the equal sign, we collect all our like terms. 9 plus 16 is 25, right? Is equal to c squared. Let's count the blocks here and see how many blocks we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Interesting. If I take a square that uses this side plus a square that uses this side, does it give me a square that uses this side? What's the square root of 25? Okay, because we're looking for c. We take the square root of that, and c would be equal to 5, okay? So this side is 1, 2, 3, 4, 5 units long. 5 by 5. We've just informally proven that if we make a square using the length of one leg on a triangle and make a square using the length of the other leg of the triangle, it's going to give me the same area as a square that uses the length of the hypotenuse. Okay? That's Pythagorean theorem. That's an informal proof of Pythagorean theorem.